Hey there, I'm Natasha, Senior Business Specialist and Instructor at the Center for Local Business Development. In our last session, I took you through Section 2, where you were introduced to the offshore project lifecycle, starting with the exploration phase. In this section, we will review the next stage in the offshore project lifecycle, known as the development phase. If commercially viable reservoirs of oil are confirmed during exploration, the project moves into development, which lasts from 1 to 5 years. Guyana's offshore industry currently sits in the development phase. This stage presents the greatest opportunity for local content. The key activities in this phase involve field development planning, drilling and completion, infrastructure, construction, and installation. Development requires extensive analysis and planning to guide crucial decisions regarding the number and design of production wells and the type and conformation of surface and subsurface facilities. All development activities and investments are related to preparing a field for production. Extensive analysis is taken on to determine the configuration of surface and subsurface facilities. This by far the most capital-intensive phase of an oil and gas project. Recall that a significant level of investment is required for an offshore project. The first step of the development phase is called Field Development Planning, or FDP. FDP includes all activities and processes required to develop a field, including environmental impact, geophysics, geology, reservoir and production engineering, infrastructure, well design and construction, completion design, surface facilities, and economics and risk assessment. Some of the key parameters established include the number of wells to be drilled to reach production objectives, the recovery techniques to be used to extract the fluids within the reservoir, the type and cost of installations, the separation system for gas and fluids, and treatment systems needed to preserve the environment. There are different types of wells: vertical, horizontal, and deviated, all which may require a variation of tools for completion. Ultimately, FDP decisions are driven by a combination of technical feasibility and economic performance. The additional challenges presented by offshore oil and gas operations translate into significant higher cost when compared with onshore or nearshore operations. The cost of drilling wells varies by water and well depth. The drilling rig rate for deep offshore can be as high as $1.5 million per day when demand is high, while onshore rig rates rarely exceed $20,000 per day. Offshore deepwater wells can cost between $60 million to $240 million using the Gulf of Mexico operations as a benchmark, while the average cost of a well onshore is around $8 million, using a U.S. onshore project as a reference. The reason for this large difference is explained by all the additional high-tech equipment and processes required for offshore developments. After field development planning, development drilling and completion can commence. Drilling of production wells during the development phase follows the same process as drilling during exploration. However, during production, wells are completed. Since oil and gas must flow for long periods in production wells, additional processes and equipment are applied to the wells. The key design principle during the completion stage is to maximize well productivity and recovery. Major activities involved in completion include installation of production casing and tubing, cementing, installation of zonal isolation equipment, perforation, stimulation and fracturing, logging, and finally installation of wellhead equipment. During the development phase, the production infrastructure and facilities are built and installed. These activities involve significant engineering, fabrication, and logistics, requiring thousands of man-hours and thousands of tons of steel. Deep offshore infrastructure mainly comprises the surface facilities such as floating production units and the subsurface infrastructure such as subsea systems. Floating production units such as an FPSO or floating production storage and offloading unit are fabricated in specialized fabrication yards and then towed to the field, hooked up and commissioned. FPSO contracts for Liza Phase 1 have been awarded to SBM Offshore, a firm with expertise in floating production systems for the offshore industry. The technology, skills, and facilities required to construct an FPSO are not currently available in Guyana. While the infrastructure for the offshore environment, like an FPSO, requires significant expertise, there is greater potential to locally source onshore services. Guyana Shore Base Incorporated, or GSB, is an example of a Guyanese company contracted to provide onshore infrastructure and services. In 2017, GSB was awarded a contract by ExxonMobil to build out the shore-based facility and provide shore-based services that will support its offshore operations. Over 90% of the staff at the shore-based facility are Guyanese. Let us keep in mind the level of specialization necessary to operate in the offshore environment and to provide deep offshore infrastructure. Let's focus again on the offshore infrastructure. Subsea systems must also be constructed and installed. This equipment is installed on the subsea surface and is later connected to the FPSO. Subsea systems comprise of equipment such as umbilicals, risers, and flow lines produced by specialized OEM or original equipment manufacturers. What do these systems do? Subsea separators separate gas and oil from sand before being transferred above to the FPSO via SURF, or subsea umbilicals, flow lines, and risers. Other separators remove water to then be injected back into the reservoir to maintain pressure. A subsea tree is fixed to the wellhead of a completed well to monitor and control well production by managing fluids or gas that are injected into the well. These subsea trees are an assembly of valves, spools, and fittings used for oil, gas, and water injection, also known as Christmas trees in the industry. The subsea installation process requires the use of offshore construction vessels and specialized ROVs or remotely operated vehicles. In Guyana, subsea contracts have been awarded to Saipem, who will perform the installation of the SURF. Construction and fabrication of deepwater trees has been contracted to Technip FMC, who will also supply manifolds and associated controls and tie-in equipment. At the final stages of development, the FPSO and subsea systems are installed and connected in preparation for production. Remember that during the development phase, there is a spike in capital expenditure. Many specialized technical services are still required. However, there are significant local content opportunities compared to the exploration phase. Support for shore-based logistics offer local content opportunities. Take, for instance, engineering, procurement, and construction companies, or EPCs, provide a broad range of services, and each of these EPCs will require onshore support like IT services, catering, storage, and office supplies. Each of the development activities listed will require contracts with different Tier 1 suppliers or prime contractors. As you start to better understand all the activities involved during the development phase, think about the support services prime contractors could need as they set up their operations to work offshore Guyana. Remember that the industry in Guyana is currently in the development stage and expected to move in the production phase by 2020, when the Liza 1 production is expected to commence. We'll learn about the production phase in the next section. But in this section, you have learned about the development phase and its main processes. Field development planning and the steps involved, such as the EIA and parameters to be determined, well cost, development drilling and completion and the various methods to fulfill drilling activities, infrastructure construction and installation, the offshore infrastructure involved and how infrastructure like the FPSO and subsea systems work together, FPSO installation and the services and companies contracted during this phase.
Natasha, why is the development phase the most capital-intensive phase of an oil and gas project? What activities are included in this phase?
During development, many activities are undertaken to prepare an oil field for production. There is a surge in capital investment as design is finalized and infrastructure is completed and installed. There are three main activities in the development phase. Activities are a part of field development planning, including all design and assessment, drilling and completion, drilling the well to prepare it for production based on design and assessment from field development planning, and infrastructure, construction, and installation, where the build-out and installation of production equipment like the FPSO and the subsea system occurs.
Environmental concerns are important. What types of assessments are done during development to take environmental concerns into consideration?
Oil and gas companies undertake environmental impact assessments, or EIA, to account for environmental risk of an oil and gas project. While these are called environmental impact assessments, they generally include the economic and social risk assessment to take these factors into account for a project as well. The process of an EIA relies on data and surveys, which can include surveys from population and stakeholders affected.
What are some of the local content opportunities during the development phase?
In addition to the opportunities mentioned earlier in the exploration phase, there are further opportunities in indirect services due to the increase in activities and contracts during development. Contractors will need support services in the areas of telecommunication, real estate, medical, safety equipment or PPEs, payroll services, office space, fabrication, inspection, equipment certification, communication, and machine shops, just to name a few possibilities. Put another way, onshore services, such as shore-based support provided by GISB, are services that are more likely to be locally sourced than services needed in the offshore environment. Remember that you can review this section at any time, and if you have additional questions, please post them to the course forum where a CLBD member can address your question. You can also visit our website at clbdguyana.com to sign up on the supplier registration portal and find updates on our course offerings. In the next section, we will look at the next phase after development in the upstream offshore project lifecycle, and that is production. I'm Natasha Gaskin-Peters. See you in my next class as we continue to explore the offshore oil and gas industry in Guyana.